Today in Copechi's Corner, we're going to look at ratio and proportions. A ratio is a comparison of two numbers by division. The ratio of one number to another number is the quotient when the first number is divided by the second number. So let's take a look. If we have the ratio of 6 to 18, first of all, this right here, this number is going to be your numerator. And the second number listed is always going to be your denominator. So we'll put them as 6 over 18. And again, whenever you do a ratio, you always want to see if you can simplify it. So we'll put that as equal to 1/3. Sometimes you'll see that written also as 1:3. Either way is okay. Okay, let's look at the second one, the ratio of 30 to 24. So again, 30 is my numerator, 24 is my denominator. That simplifies to 5/4. Now we want to leave this fraction as an improper fraction, No mixed numbers. Now, the reason we don't want a mixed number is because, remember, a ratio is comparison of two things, the numerator compared to the denominator. If I have an improper fraction, for instance, if I change that to 1, if I change that to 1 1/4, that doesn't help me, right? What am I comparing? I can't just say 1 to 4 because I have that whole number 1 in front. So that's why we always leave it as an improper fraction. Now, if we have something like the extended ratio, meaning we have more than two, then I'm still going to simplify that. So I can see that 5 goes into each of those. So that goes as 2 is to 1 is to 12. I'm not going to put it in any sort of fraction form. It's just going to stay like that. Okay, now we're ready to look at some geometry within there. Okay, so I have find the following ratios. AD, segment AD, so that's 10x is my numerator, and BC is over 8. So that simplifies to 5x/4. Okay, letter B, we can do the same thing with angle measurements. So A is 50, D is 130, and that simplifies to 5/13. Now in letter C, it talks about angle D to angle C, and actually we should have measurement signs in front of there. We're comparing the measurements. We don't know what angle C is, but if I look at this, these are parallel. So that makes this angle and this angle right here same side, and then we know that they are they have to be supplemental, right? So that makes that second one 90. So the measure of angle D, which is 130, over the measure of angle C, which is 90, that will simplify to 13/9. And like again we discussed, we're going to leave that just as an improper fraction. Okay, we're going to need to have a quick reminder about the metric system. So I'm going to scroll down here. You can just find a spot somewhere in your notes to write this. I think some of you learned it this way in middle school. I think it's a great one. It's a phrase, King Henry drinks Ucky dark chocolate milk. So each of the letters stands for something. Okay, so our Ucky stands for the units, whether it's meters or liters or grams, anything like that. And each way I go, this is getting smaller, right? I'm moving my decimal point one spot. These right here are getting bigger. And so we're multiplying those by 10. Again, moving everything one decimal. So for instance, if I'm looking at meters and I want to know how many centimeters, we know that 1 meter is 1, 2. So that's a 10, 100. So it's 100 centimeters because meters is bigger than centimeters. So you need 100 of those to put together to get to a meter. Okay, so now let's see. We're going to use that a little bit here. Okay, so we say a poster is 1 meter long and 52 centimeters wide. Find the ratio of the width to the length. Now, what I like to do is I like to write the words first. Again, the width is listed first, so that's my numerator. Over the length is my denominator. And I know that my width is 52 centimeters. And I know my length is 1 meter. Now, like again, we discussed 1 meter is the same as 100 centimeters. So this is going to be 52 centimeters over 100 centimeters. Now, what happens is once the units are the same, this gets canceled. It simplifies out. And I'm left with 13 over 25. That's the ratio. I don't need a unit to that. It's just the ratio. Okay, let's look at the next one. A mirror is 2 feet wide and 34 inches long. Find the ratio of the width to the length. So again, we're going to say width first. And then I'm going to say length. My width, it says, is 2 feet. And it's 34 inches long. And as you know, 1 foot is the same as 12 inches. So that 2 feet on the top is going to become 24 inches. And on the bottom, I have 34 inches. So again, I can cancel my inches because they're the same. And that simplifies to 12 over 17. That's my ratio. Again, I can't cancel those units until they're both the same. Okay, here comes some more geometry in with our algebra. It says the measures of 3 angles of a triangle are in the ratio of 2 to 2 to 5. So again, we have 3 angles of a triangle. I have 3 numbers. Okay, it looks like 2 and 2, right? It looks like those measurements are going to be the same. Find that measure of each angle. Well, I have some unknowns there. I don't know. I do know that a triangle, when I add it together, the interior angles add up to 180. So my unknowns, I'm going to take 2x plus 2x plus 5x, and then I'm going to solve for x. So this ends up giving me 9x is equal to 180, so x is equal to 20. Find the measures. Well, 2 times 20 gives me 40. I have another 40, and then 20 times 5 gives me 100. Now, the nice thing about this is all degrees. The nice thing about this is I can check that. When you add them all together, do you get 180? Which we do. Okay? Why don't you pause the video, try this one, see how you do. The measures of 3 angles of a triangle are in the ratio of 3 to 4 to 11. Find the measure of each angle. So I'm going to do the same thing. 3x plus 4x plus 11x is equal to 180. When I add those together, I get 18x is equal to 180, and x is equal to 10. So my measures of my angles are 3 times 10, which is 30, 4 times 10, which is 40, 11 times 10, which is 110. When I add those together, I get 180, so I'm all set. Okay? Moving on. The ratio of 2 complementary angles. So I have 2 angles here. Complementary means that they add up to 90. So I'm going to do the same sort of thing. I have 1x, right, plus 2x is equal to 90 because when those angles are complementary. So this gives me 3x is equal to 90, so x is equal to 30. So I have my 1x is 30, my 2x is 60. Again, when I add them together, I get 90, which is what I wanted, so I'm all set. Moving on to example 10. Again, if you want to try this, you can pause the video. The ratio of two supplementary angles this time is 2 to 10. So I have 2x plus 7x. Supplementary means 180. That gives me 9x is equal to 180 and x is equal to 20. So again, substitute it back in. I have 40 and I have 140. Add them together, I get 180. All right, let's look at one more. The measures of the angles of a quadrilateral, all right? So there are 4 sides, 4 angles. Remember that a quadrilateral, the inside, all the sum of those 4 angles are going to give you 360. So the same idea, except for we're using 360. So I have 7x plus 8x plus 9x plus 12x is going to give you 360. Combine my like terms. I have 36x is equal to 360, so x is equal to 10. My measurements of those are 70, 80, 90, and 120. And when I add them together, I do get 360. Now, again, the question could have said, in this case, the question said, find all the angles. It could have said, give me the measurement of the smallest angle, or give me the measurement of the largest angle. So there's a lot of different ways the final question could be worded. Okay, thanks so much for stopping by today. Have a good day.